Alright, ladies and gentlemen, welcome back to the channel. Today's project is this older Acer laptop, and specifically I want to deal with its battery on the heels of my success with resuscitating iPad battery, which you may have seen in my other video. I don't know if I already posted it at the time of this video or not, but it will be posted. So the problem what we have here, the laptop works great. I did open it up some time ago, unfortunately didn't film it, cleaned it up, that fixed some cooling issues and whatnot. So that works great, except the battery is not really holding charge. And by not holding charge, I mean at all. So when it's plugged in, like you see right now, it is plugged into the mains, it works fine. However, as soon as I take the charging cable out, it shuts down immediately. So I don't mean lasts just very short period of time. I mean it just cuts off. And yeah, I had an unfortunate incident when I was actually imaging the hard drive from this laptop to upgrade the SSD. And I didn't even think about that because all I wanted to do is really transfer from one mains to another mains. This laptop is primarily being used with the mains anyway, but sometimes it's nice to be able to unplug and replug it to another socket. And that totally doesn't work with this one because as soon as you unplug it, it goes out. So let's see. Let's see how that works. Okay, so I have it. Okay, let me show you the screen. All right, I'm sure I could have done a better job at that, but basically, okay, you can see this is a battery info view, and it shows you the right type of the battery. Yeah, that is correct. And some other information here, but a lot of that is a lie. Yeah, I see it tells us that apparently the battery health is at 81.6%. No, that's a lie. And let me just show you what happens when I take the... Yeah, and by the way, yeah, as you can see here, so one thing what is Windows is reporting is that the current capacity in percentage is 100%. So that means it's 100% charged. So it's an AC power. So yeah, that's that. And let me just pull a plug. So 3, 2, 1, and there we go. So that's that. All right. So with that, I think that's pretty clear what we need to do. Well, actually, I don't know what I need to do. I'll need to take a look at the battery and see what we can do with that. I mean, the obvious solution, if nothing else works now, would be to replace the battery, and that's an option. But let's see if we can actually try to resuscitate it. As I said, all I want from it is just maybe a few minutes of runtime. I don't really need anything more than that to be able to replug to a different power outlet. So that would be good enough. I mean, if we can do better than that, that's great, but we'll see about that. All right, so now, okay, let's turn it around, and we'll need to take off the back cover. And I already removed, there's a lot of screws in there, so they're all here. I took them out. There's nothing to it. They really, they're not even particularly small one. That's a fairly heavy laptop. Okay, now we need to be able to split it out. Yep, and I don't have any tools for that because it was already opened. Yeah, pretty much there. And there we go. All right. So probably need to disconnect some cables here. Yes. Yes, we do. Okay, so that's one latch. That's another one. Now we should be able to pull this. Yep, this one is out. And this one. And here we go. Yeah, it's actually the white latch here, but actually needs to be lifted up. Like so. Now, should be able to pull the cable. Yep, just like that. Okay. All right. I think we are disconnected. All right, and now the keyboard and a couple of flex cables are out. Is out. All right, so what do we have here? Let's see. Yep, it's all good. Again, I already disassembled it and yeah, replace the hard drive with SSD and things like that. But right now we're interested in the battery. Okay, here's the battery. Looks to be a 3-cell battery. And let's see how does it connect. Oh, it's just, I think there's an extra dummy section here, so it probably can accommodate 4 cells. Okay, so there's one screw in there. All right. Yep, just latches here. Okay, nice. No glue, thank you. Yep, there we go. All right. Okay, so the big connector, the battery connector is here. So let's zoom in. Okay, no latches there, just friction fit. And voila, there is our battery. So looks to be original Acer battery, AC14B18J. So 3 series. Okay, let's see what else do we see here. Okay, 11.4 volts, so that's 3 cells. And more than 3 milliampere hours. 3000. So, all right, that's less than reported, but okay, so let's see what we can do with that. You can see plus, so it looks like it's likely to be, actually I don't know what the pinout for the connector is, but we know the positive, sorry, negative and positive. All right, so okay, we don't need our laptop for now. Let's take it away. All right, and here's our battery. Okay, I'll need to investigate first. What do we have here? So here's our multimeter. All right, I have to change to a different multimeter, as the other junky one wasn't even compatible with the proper lead connectors. Anyway, so let's see what we have here. So we are in DC volt mode. And just to make sure that we are measuring things, it's always good to check. Here's my annual loop. And okay, if we just make a connection here. Yep, 1.33. If I just be able to hold it, yep, 1.338. Yeah, so like normal annual voltage. Okay, so let's see what we have on the connector here. So it tells us that as usual, black is negative and the right red is positive. Okay, so let's stick to the common. Okay, and let's see. Well, not really nothing. 0.004. Actually quite similar to what we saw in the iPad one. So basically completely out. Let's see if we see any other voltages here. Okay, let's check another route. Yep, 003. Okay, we have some voltage on the orange. Just jumping up and down. Probably some kind of communication bus or something. Maybe temperature. Still very low voltages though. So yeah, I'm not sure what that is, but we're certainly making a contact, so that's good. Okay. Nothing on yellow. Basically nothing on green. Basically nothing on blue, and of course nothing on black. Okay, so let's just recheck. Yep, we still see 3.34 millivolts. I mean, I can switch to millivolts mode, even though again, that really doesn't match. It's for all practical purposes 0. Yeah, so 3.8 millivolts, 3.7. So it is consistent. 3.7, the same. Yeah, on the orange one, we have something going on there. But see, I don't know what this connector is, and yeah, basically nothing on the other ones. Okay, all right. So that's good for now. So what we can do is we can try to again connect to the plus and minus. I probably wouldn't want to do through this connector. I don't want to break the connector. It's pretty, yeah, looks very fragile. So instead, I either hook up directly to the wires, like I can hook up here. Again, these do not look amazing here. However, what I would probably want to do is to actually open up the outer packaging, either here or probably on this side actually, very carefully. Remember, this is outer envelope, that's not the cells packaging. So we'll try to open it in a way that we don't disturb it, obviously. And so that we can expose the terminals of the actual cells inside, because unlike our iPad endeavor, where it was kind of easier for us because it was one cell, single cell, in parallel, hence we could just hook up to the terminals and just charge it as a single cell. These ones are in sequence. So ideally, you want to be careful about just like hooking up the end terminals and charge it with 12 volts. The reason being, if they're all kind of in the same state, then that's probably fine. But we want to be balanced. So like if one of them is not as good as others, so maybe like two of them, maybe them are charged, and one of them is bad, as in discharged at least. Charging through the end terminals would not be a great idea, well, for a variety of reasons. That's what balanced chargers are for. So then we'll see if we can either charge individual cell here to bring it up to par with the other ones, or we'll try to hook it up to the as an actual balanced connection and charge it with our balanced charger. So we'll see. But first, I think I'll need to expose the terminals. It's kind of hard to tell where are they on which side. In all likelihood, they're on this side. But it's quite possible they're on this side. So you can see a little bit of indentations there, what's going on there, but hard to tell. Certainly wouldn't, well, at least try not to use any metal tools, so not to short anything there. That would be bad. And of course, we'll cover it with tape after we are done. But for now, let's see how we can open it up. And of course, safety first, so glasses, no, but gloves, but glasses certainly. All right, so let's get started. Well, actually, we can just pry out, it seems it's just glued to the envelope on this side. So I'm just peeling out the outer envelope. Okay, I can see some metal. Tape is out. I'll try to save it if we'll see if we can put it back. Not sure about that, but we'll see. All right, and here's what we have on a battery pack. So yeah, so basically that's what I can see. I don't know if it's, yeah, that part might be soldered in. Yep, so okay, so here's our connections and probably at the bottom as well. Yep. Okay, so there's the spot welds with the probably nickel strips. So that's a usual way of making the connections in battery packs. So let's see. Okay, I can see that this one says V minus, so that's probably negative voltage. right there, and it connects directly to that strip. Okay, so that's likely to be negative terminal. And this one, what does it say? VH, voltage high maybe? Oh, no, that's something else. Because V plus, I can see now, V plus is right here. You can see V plus, and it's also connected with this strip. All right. So we can actually remove now the battery pack. Like so, from the bracket. And that's what we're left with. Yeah, you can see the spot welding strips. I mean, if I have to guess, so that would be a thermal sensor, so the temperature of the battery, and I think we can see here what it says is TH something, which I think is exactly what it is. That's the thermals. Alright, so we connect this terminal with this terminal. We're touching that. But I think this terminal, which is insulated here, is getting connected here. Alright, so what does that mean? So that's the same terminal as this one, which gets connected. So okay, so this one is a negative. As far as I can tell. So this is a negative. That means this one is negative, which connects to positive. That's right, it's in a series. This one seems to be positive, so let's turn it around. And the top would be negative, so that would be negative, positive, negative, positive. So the letters get close to the negative terminal. So negative, positive, positive, negative. Wait, no, because this one is inverted. Okay, so the way it goes, so okay, negative, that connects here, then positive gets connected to the negative, then this positive gets connected to the negative, and this positive gets connected to the positive terminal. Okay, so that's our wiring of the pack. Now, all right, so with that, let's see if we can see any voltage on any of the cells actually. All right, so this one would be negative on this side and positive. It's a bit weird though. Yeah, usually, I mean, in terms of the polarity, it's actually the whole pouch, which seems to be metal, would be negative. And this side, which is insulated, sort of, would be positive. Huh. Okay. Let's see if we can get on any of the terminals here. Oh, wow, that is interesting. So that we actually have full voltage here on the cell. Very interesting. And it seems that we are correct, as in this whole metal jacket and this right side in this case is positive and this part is negative. Yeah, look at that. 4 volts plus. That's what we expect to see. Yep. Okay, interesting. So how about, yeah, and if we switch, yeah, that shows negative, so that's reverse polarity. Yeah, so that is correct. So this terminal on the left right now, my black tip, is negative. This one is positive, and we're measuring 4 volts there. Interesting. Okay, so how about we'll measure that cell. So again, and also 4 volts. That is very interesting. So these two cells show the fine voltage is fine. How about this one? Okay, this one hit negative on this side, and this cell is fine. I am very confused by that. Is that the infamous protection, like the BMS level protection of the cell? So the cells actually measure fine. Let's measure the whole thing then. Okay, here's the positive. Here's the positive, here's the negative. Yeah, look at that. 1215. Oh, there's a solid voltage right there. Okay, so why are we not getting that right here? Well, there are two options here. Well, there are probably more than two options, but one, BMS itself, the battery management system, is bad. So even though I'm measuring here all cells are good, they're charged, that also means it's actually able to charge it, presumably, because it's been a while since, yeah, this is not a new battery. Yeah, 12 volts. Okay, so what do we get on the temperature? Yeah, we'll need to measure the resistance. Yeah, I mean, it measures something, 5.6 kilo ohms. I have no idea what the temperature it corresponds to, but I mean, that doesn't look entirely bad. And what do we have for this VH? Oh, okay, so that's our partial. Yeah, so that's 8 volts just for the two cells. And here's our full charge. Okay. So why are we not getting the output at the connector? So again, if the BMS is bad, which sounds kind of unlikely, or it has some kind of protection, wherever it's based on voltage. I mean, it's unlikely to be based on voltage because the cells are fully charged, and it's unlikely that they would last that long without BMS actually charging it. So maybe it is actually doing it based on, yeah, look, nothing. Based on the number of charge cycles, or just, well, I don't know about time, probably charge cycles, something like that. And that would suck. There are certain battery packs that operate this way, and I'm not sure it's something we can do about that. I may want to do some more research, but as of now, this is actually an interesting case that the cells are perfectly salvageable. I mean, they're fine. They have full charge. Nothing's wrong with them by the looks of that. But I can't use them. So if I can only get another battery, which is basically the same BMS, but with bad cells, then I can swap them out. But for now, not really. I need to do some more research, but not looking very promising for now. So let me see what I can do, and we'll see where we can take it from there. So I think I actually finally figured it out. That was not one of the issues that I thought is actually an issue before. And as I mentioned, I thought that could be an issue with BMS on the battery going bad, which was unlikely, or the battery going into protection mode after, well, either it experienced low voltage event or just based on the number of discharge recharge cycles, which some batteries do. Actually, I don't think any of this is an issue. In fact, I think actually our battery was perfectly fine. So there's a third thing why we don't see any voltage on the battery terminals. And as it turns out, at least on the Acer laptops, they have another mechanism to disable the battery, or at least the voltage on the terminals, and that's actually the intrusion detector switch, which basically cuts off the battery if the laptop thinks that, well, it's open, just like here. In this case, the battery is cut off to prevent damage to the motherboard, which is not necessarily a bad idea, but I certainly didn't know about that. So let's see what happens here and why I think that could be the case. I actually have to dig out the schematics for the motherboard and, well, for the laptop in general. And actually I found the pinout for the battery connector, which is here. So as you may remember, actually, let me see where my battery is here. Deconstructed. Yeah, there we go. So that's the 8-pin connector here. And 4 of these are fairly straightforward. So there's a ground. Okay, let's just see what we have here. All right, let's get into the resistance measurement. Right, so again, if I get the colors here from the connector, and that goes exactly like that. So the left, from that perspective, 2 pins are ground. So that's the 2 black wires, that's the ground, and let's do some zoom here. Magnification, I think we can, yeah, I can still see the multimeter. So yeah, that's the, and let's look at the, yep. So the left 2 are ground, same as the case of the connector. The right 2 pins in the connector or in the battery wiring harness are red ones, and that's the positive of the battery. So that's these 2. Now, then what we have is right next to the 2 black wires on the, let's see if we can just show it up. Yeah. 2 black wires on the left, that's ground. The next ones are blue and green, and this is a data transmission for this main smart battery. I don't remember which one is which. One is the data signal, another one is a clock, and maybe I'll put up the pinout on the screen when making a video. I don't remember what the yellow connector is. again, will be on screen. It's either temperature or some other related to the data transmission line. But the interesting one is the orange one, which is right next to the, so that's the third from the right, and that's right next to the two positive battery lines. So that is actually a disconnect switch for the battery. So basically, in order for the battery to show up the voltage on its terminals, so the left and right, or black and red, this line, which is, okay, let's see if we can zoom in, which is this orange wire on the harness, or the third pin from the right, needs to be connected to the ground. Without that, the battery is, well, exhibiting all the symptoms which we had. It shows up as dead. So let's see how that works. So let me just connect the ground. And the third pin right now. So 1, 2, 3. Yeah, so basically open line, no connection right now because the case is open. So it correctly figures out that, we shouldn't be really connecting the battery to anything. So now if I'll just keep that, if I can do that. So let me show the actual switches. So in this particular case, the switch is right here. That's the button that could be pressed. Let's see if we can zoom in some more. There it is. In this particular case, the markings are SV, so switch 1. So I'm clicking it right now. All right. So let's see how that works. Just move it back. All right, so 1, 2, 3, third pin. Okay. All right, I think I'm holding it right now. So open line, without button pressed. So now if I click on the switch, let's see what happens. Ta-da! 2.4 ohms. So definitely I release it. And it's open line again. Click it and it shorts, well, not exactly shorts to the ground, but connects to ground at some resistance. All right, so that's a very positive news. So, okay. So let's see if we now connect the battery. Okay, let's switch to the voltage mode. Let's connect our connector, battery connector, to the board. And repeat the same exercise now in voltage mode measurement. And see what we have. Remember, so if we measure positive to negative voltage like that, as we did before, we just saw basically nothing. Well, right now it shows point. Yeah, I think of some charge dissipating or something. Basically, yeah, 0.010, I think it's going down below. So basically no voltage between positive and negative on the battery terminals. However, let's check that out if we'll be pressing the button. like so. And actually, what is well, I don't think that's going to happen like that. Okay, so let's do first that. Okay, so now, see, we have no voltage right now. I'm pressing the switch. And look at that. Yeah, my connection is not ideal there, but yeah, you can see, yep, 12 volts coming in. I release the switch and it drops down to nothing. All right, so it seems, and actually just for kicks, now I removed the leads because it's kind of like inconvenient here. So let me show you that it does indeed work. So first of all, how do we do that? So I think you can see the screen just a little bit. So right now it's dark, and as you can see, there's no power connector to the mains, to the charger. And right now the battery is connected. So yeah, right here. So here's the switch, the main power button, microswitch. So okay, so if I just press that, see, nothing happens. Nothing happens, fan is not spinning, no lights, no nothing, yeah. Which is exactly as expected, because right now we have no mains connection and we have no voltage on the battery terminals. But if I actually press this switch, the intrusion detection switch basically, and hold it, simulating that the case is closed, and then press the power button, let's see what happens. So now I'm holding the switch, intrusion detection switch, and I press the power button. And look at that, lights up, and you can see the screen. It's turning on, and the laptop is on. So everything is working. And just to demonstrate that that's the switch, so I'm still holding it right now. So let's see what happens if I just release it. Boom. Everything shuts down because battery gets disconnected. So that's that. Mystery solved. So that's great. What's not so great that I didn't have to actually take the battery apart. However, again, like for entertainment purposes and education purposes, that's great. So now we know how it looks like on the inside. If you somehow find one of the dead cells in a pack like that, you may try to replace just a pack like that after disassembling. It's a bit tricky because, again, it's kind of hard to, unlike the cylindrical battery packs, these cells are hard to find separately unless you have another battery pack that actually has good cells but bad BMS or something. So you can replace it, but in this case it seems like battery was perfectly fine, and it seems to be perfectly fine. Again, I don't know about the actual capacity, but that's a separate story. That's not what I was trying to achieve here. It's perfectly functional for what I wanted it to do. And the issue is this microswitch, the intrusion detection. And apparently I did some digging, and it's not uncommon issue, at least on the Acer laptops, and actually a variety of them. Because in some cases it's located, well, in this case it's located on the motherboard, being held under the keyboard. In some cases, if there's a separate window to replace the RAM chips, memory chips on the back, in this one it doesn't work like that. This one, I think, if I remember correctly, the memory chips on this one is actually on the other side of the motherboard, so you actually have to disassemble the whole thing to upgrade that or have access to that. But in some models of Acer laptops, you have a separate window at the back of the laptop itself that you can unscrew and just have access directly to the memory slots. And that memory door actually has a microswitch underneath, the same like this one, similar microswitch. And basically, and I can show you on the, so there's a pad. So in this case, that's my keyboard. It goes like that. And it seems to be that that is the pad. And it's sort of like a rubber or foam. Alright, so I wouldn't call it exactly as good as new, but surprisingly decent for what we were supposed to be literally just tearing the tape out. I'll add a little bit of electrical tape. Because remember, like the purpose of this wrapper is really to insulate the metal surfaces of the batteries from the rest of the case. And for that purpose, it will do just fine. We'll just add in a few spots where we have tears and exposed metal, some electrical tape, and that should be good to go. Alright, so let me just fetch my electrical tape. Alright, that's done. That actually went faster than I anticipated. Looks pretty decent if I say so myself. For what it is, no exposed metal surfaces. Yeah, should be good to go. Alright, so here's our laptop. Alright, battery connected. Let's check it again. Yep. Lights up, fan is on. Screen is on. Alright, well, good. And I just turn it off. Yep. Lights off. Okay, so battery is connected. Now let's actually make sure it's attached properly. And it just snaps in. The latch is here at the bottom, yep. Perfect. Seems good. So we had one screw in there. All right, so battery is secured. Now to fix this switch for the pad. All right. So here's our pad. So you know what? Let's just use the same electrical tape. I'll just add a few layers on top. I think it's like 7 layers or something. I'll see if that helps. It should help. All right. Now to make sure that actually our switch is pressed tightly, let's make sure we put some screws right in this area. No mains connector. All right, let's see. I can see a light, and I can hear a fan, and the screen is on. And we're running without a mains connector, which was exactly the whole point of this exercise. Amazing. So that's done. I'll test the keys later, but it seems like it's all good. So I will turn it off for now. Add remaining screws, and then we'll see what the battery report tells us now. Oh, I missed one, yep. And I thought, dang, there's one extra screw left after disassembly and reassembly. That's usually not a good sign. But no, you can see nothing's left in my screw ball. All right. Yeah, and by the way, yeah, here is the model ES1-531 series. All right, so let's boot it up and see what the battery report tells us. And here we are, all booted up into Windows. So let's see. And look at that. That's the site we haven't seen before. And that is discharging. That's not something that happened. So if you remember, as soon as we pulled out the plug, that would just disconnect, which is, now it all makes sense. So everything looks normal. Again, the battery I'll need to recalibrate, but again, like, I'm not overly concerned about the actual capacity, even though it seems to be actually probably quite decent. Yeah, I did check. Yeah, as you can see, the trackpad is working. I did check the keyboard. Keyboard is working, so that's fine. And let's see if we just connect the power. Alright, and let's refresh. Yep. Okay, there we go. AC power. Capacity 100%. Everything is good. And let's disconnect again. And refresh. Well, first of all, we are still, as you can see, not dead. Working, and we're back to discharging. It's perfect. It's all working. So that's great. Despite the fact that we didn't have to disassemble the whole battery, the battery turns out to be perfectly fine without any touching. The issue was somewhere else, but hey, like, live and learn. Sometimes the issue is not where you think it is, and we recovered quite well and found out something interesting along the way, how the LiPo battery packs look like on the inside, how to measure them, how to find the pinout of the connectors, and so on and so forth. So I think that was great. So if you like this content, again, click the like, subscribe, let me know in a comment if anything that you really liked, that you really disliked, what you want to see more, or anything in fact it's constructive. I'm happy to see you. I reply to all the comments, well, most of them, and I'll see you next time.